So look, thank you to those who are attending here, and for those who are watching this video after the fact, thanks also for your interest. This is just a bit of an information session about CSU Engineering, what we're about, and our course offerings and some of the information around how we do things. It's really just a chance to give some of that high level information, but myself, my colleague Peter, who's in the meeting with us here today, and any of the rest of our team are more than happy to answer questions that you might have. So please get in touch if you do have any that aren't answered by this question. So look, CSU Engineering, we have been a School of Engineering for about 6 years now, so we're reasonably new. And we were founded with an idea of doing things a bit differently in terms of how we teach engineering. So a couple of points: we don't do lectures at all. So we're not one of those universities where you're going to sit in a hall and listen to someone talk at you for hours at a time. And we also don't do exams. We don't put you in a high pressure situation, sit you down for 3 hours and say, design a bridge or something like that. What we do instead, we do hands-on engineering. We do project-based learning. We do real-world engineering projects, and we help develop real-world engineering solutions. So it's really about actually doing engineering as a part of your study, as opposed to just trying to learn it purely from a theoretical perspective. So we like to say we do engineering, it's engineering done differently. So what does that actually mean though in terms of how we actually deliver this content? And I'll talk about the course offerings that we have a little bit now. So this is our course structure, and I realize this diagram or these diagrams are probably a bit involved, the big spreadsheets or big Excel tables here. But if you look at the one on the left there, that's our main degree, or the degree that we've had operating for the longest. So we started with this degree. It's a combined Bachelor of Technology and Master of Engineering course. It's 5.5 years in total, and this lists all of the subjects that you do as a part of that degree. If we start from the bottom, that's where you begin with Engineering Challenge Zero, and we do 3 hands-on project-based learning activities across your first 3 semesters of study. We then also back this up with the topic tree subjects, which you'll see on the right-hand side of that diagram there. And that's where we get the theoretical information and get that content into you. And I'll cover the topics in a bit more detail later on. The first red line there is sort of a hold point, and that's where you finish your on-campus study. And after that, that's when you move on to your first placement as a junior cadet. And you do 4 of these placements over the next 4 years, continuing your theoretical topic study, and also doing some other professional development subjects, which are the red ones in the middle there. And you also do 2 theses as a part of your work whilst you're on placement. And again, they're designed to be real world problems that your host organizations or other organizations might have problems that need to be solved. So the second red line there is sort of the whole point at the end of the Bachelor of Technology point. And then the last subjects, the last 2 years, are the master's component. Over on the right-hand side here, I have our new Bachelor of Engineering course, which we're launching this year. So the first intake will be from the end of February this year. Very similar for the first 18 months, and even actually, sorry, for the first 2.5 years. So it's 18 months on campus, a 1-year placement, which is sort of after the red line there. Then from the blue line, you come back to campus and you do 18 months back with us before graduating. So 5.5 years for the combined degree, 4 years for the bachelor degree. It's important to note the first 2.5 years of these degrees are common. And what that means is if you've enrolled in one or the other and you want to swap, you can do so freely up until that 2.5 year point, provided you're on track with your studies. So that gives people a lot of flexibility with coming in, as to decide, okay, I really like working in industry. I want to keep working in industry, do another placement. I'd like to go down the combined degree path. Or no, I just want to get this done. I want to get back, I want to get my studies done and get into the workplace as a graduate. I can go and do the 4-year option. So there's sort of some flexibility around that. The other 2 ones, and look, there may be people here who are looking at other options. The Bachelor of Technology, which is in the bottom right-hand side of my screen here, is effectively the first 3.5 years of the combined degree. So it's up to from the bottom up to the top red line there. So that will allow you to exit. I mean, if you're enrolled in the combined degree, you can study to that point, then exit with this Bachelor of Technology degree. And that's probably designed for those people who maybe don't want to get a full engineering degree, but are looking to still practice in that field and sort of like the more, I guess, the more routine type activities that are involved in a career in engineering. The one in the top right here is our Master of Engineering program. And that is effectively the top, above the red line on the left, the top 2 years or the last 2 years of the combined degree. This is really designed for people who have already been working in the industry and maybe have some sort of qualification to upskill and to develop. It's also worth mentioning that this degree is designed around registration and chartered status. So for those who are interested in that pathway or who need to get registration, this is a pathway that allows you to do that either with a associate degree, a Bachelor of Technology, or a degree from overseas. You can use this master's as a pathway to getting registered in Australia. So I realize that's a bit of an information dump, but I just wanted to be clear as to what we offer and what the options are, and just talk you through that. So a couple of the pieces that I talked about there, sorry, these are the highlighting again that these are effectively all the pieces. They're just being cut up differently. So the combined degree has these two components that you can do separately depending on what you're looking for from your studies. Okay, I mentioned placements. Placements are a big part of what we do. In the traditional combined degree program, you'll actually do 4 years of placement. The Bachelor of Engineering, you'll do 1 year of placement. The Bachelor of Technology, you'll do 2 years. And the Masters of Engineering, you'll do 2 years of placement as well. So we liaise very heavily with industry organisations, so engineering companies, local councils, state government organisations, private company organisations, to arrange placements with them. They are paid placements. You are employed directly for the host organisation. You work for them 4 days a week, and then you have a 5th day for study or for some of your study purposes, which is an arrangement we have with those host partners. Both Peter and myself have come from industry before we worked in academia. We have connections with industry, so we help source some of the placements. Some of our colleagues likewise have a lot of connections in the industry. So we have quite a good network that we like to draw on to bring in these placement opportunities. The other option, of course, is if you maybe know an organisation, you may have connections through your school studies or through your family or through other networks. You can effectively bring your own placement. So you can go out and engage with another company and say, if they're happy to host you. It's worth noting that we do have some quality assurance steps we need to check as a part of that. So you can do it, but you just need to make sure you meet our requirements. Whilst you're on placement, you have a workplace supervisor who's someone that we have trained up to support you in your studies and your work placement, and you'll also have an academic mentor from our side. So you've got support from both sides there. This whole process, the placement process, is designed to integrate with your studies. So the thesis that you do on placement will be aligned to a workplace problem. The topics that you do will support your work placement. So it's really been designed to integrate together so that you should be able to access the information as and how you need it to support your learning. Just a bit of a snapshot. These are the placements from last year. So this gives a bit of an overview of where we have cadets currently placed. You can see here the little legend has the 4 different colors, which are the 4 years of placement. So junior through to professional. And the pins are obviously where they're located. So we have geographically spread more or less across all of New South Wales and then a little bit up into Queensland. But that shouldn't necessarily limit your potential. If you wanted to place in Melbourne or Adelaide or Perth, that wouldn't be an issue. At this stage, we don't offer international placements. However, we are working towards having them available in the next couple of years. So there's just a few hoops to jump through with that. And obviously COVID's put a pretty big spanner in the works with trying to get anything internationally happening. The other main sort of item I touched on earlier was the topic tree. Now, the topic tree is a bit of a difficult concept to get your head around, but it's best to think of these as a grouping of modules of content. So they're sort of designed to be 3 hours of content to take you to complete. There's around 1,000 of these in total, and they have prerequisite links. So you've got to do one before you do the next one. You can see on the right-hand side of my screen, there's a bit of a close-up view of some of the topics and their prerequisite links. But the idea is that you'd start at the beginning. So you'd start at, say, introduction to engineering. You might go into then the physics stream, which would lead into the structural design stream and then into the advanced structural design components towards the end. So you build on your knowledge sequentially from one to the next. They're available online at any point in time. So you can log on when it suits you and knock off a couple of topics. And it's designed, again, like I said, to be flexible in terms of you can do them as you need them. So if you're working in the industry and your boss says, okay, I need you to go and design this road for me, you can go, okay, well, I know a little bit about this, but I don't know heaps about it. I'm going to go and do the topics and get the knowledge and then apply it directly to what I'm doing in my workplace. Similarly, when you're on campus, we will give you a project and we'll say, this is what you're working on. Go and find the information from the topics to support that learning. Now, 1,000 topics sounds like a lot, and it is a lot. You would typically cover about 600 of these throughout an undergraduate degree. But keep in mind, you're doing it over quite a significant period of time. So, you're not expected to knock them all over in a year. We tend to find if you do, say, four to five a week is about what you need to do to keep on track for your studies. So just some information about our admissions criteria. I realise that some of you may have already accepted offers, but for those who are still looking at whether they want to come here or not, this is just the information that you need to know. So if you're coming straight out of high school, the ATAR for the Bachelor of Engineering is 75. The ATAR for the combined degree is 80. The recommended subjects are listed there, but the main one would be mathematics. So we need you to have some understanding of calculus in particular. It would be very beneficial. I've listed there, we have what's called a study link subject, which if you're not necessarily across calculus, you can go and do that. That's a short course that you can do as a bit of a bridging subject to prepare you for the mathematical side of what the study here involves.
Josh, let me jump in there and say, guys, if that list makes you go, oh my goodness, come talk to us. For example, if you were at maths and you really struggle at maths and you think calculus, I'm not even sure actually what that is, let alone being good at it. Don't panic, because we have maths programs to start with where you're at, to bring you up to speed and teach you everything you know. So it's not like you're going to be dropped in a class and we'll say, now, everybody take out their advanced calculus, spreadsheet, and we're going to do this. We've got the tools and the methods to start exactly where you are in maths. And look, the best story I can illustrate with that is we had a guy who came in, mature age student who'd worked on mines for years, and he said, I want to do engineering. I'm not very good at maths. And so we said, well, find the level you're at. He was at 8th grade level, and we've managed to bring him up, and he's graduating pretty soon. So don't worry too much about where you are. We have the tools to teach you everything you need to know. Okay. Same with physics. Don't panic about if that list looks scary. We want you to come to study engineering, and we have the tools and the means to teach it to you.
Thanks, Peter. Yeah, no, really good points. Absolutely. We do our very best to cater to anyone who wants to come in. And I think really what you find at the end of the day is it's more about how you apply yourself and how you approach this and your attitude. And if you're passionate about getting into a career in this field and you can apply yourself, then there's no reason that that should hold you back at all. So no, good points. Just jumping back, so those who are coming not directly from school, so non-school leavers who may have done some tertiary study, if you have a completed diploma, or have done at least 2 subjects at a university level with a credit or higher average, higher grade, sorry. That's an entry pathway as well. I've just listed again the maths there. If you maybe haven't covered it, it's not a bad option to do. For those who are maybe a bit more experienced and are looking at the postgraduate options, who want to do our masters, the expectation would be completion of an associate degree, so a 2-year degree in engineering, or a Bachelor of Technology, which is the 3-year degree, and at least 5 years of experience in the industry. So there is a bit of a self-assessment process as a part of the entry to that degree. So we will have a look at your qualifications and see if we think you're suitable to come into our masters or not. The very first subject you do will be assessing your knowledge and working out where the gaps are and what additional study you need to fill the gaps for that. So again, there is a bit of a flexibility as to how we do the entry to the masters. For those who maybe don't quite meet some of these criteria, so, you know, what will happen is if you apply to us, we will look at all your information and make an assessment. And then we may come back and say, look, we think you're close, but not quite there yet. For those people, we will look at pushing you towards doing our Diploma of General Studies. And that's a 1-year program or equivalent 1-year program designed to prepare you to come into our degree. If you complete that study, you are guaranteed an offer of our undergraduate program. And that does cover the mathematical component as a part of the study for that course. So that will be something that we'll communicate to you if you apply and get an offer that.
So just to reiterate, what that means is if your ATAR comes out unexpectedly low, you can still study engineering. It just might take you a little bit longer to get there.
Yep.
That's essentially what that means. It's, you know, high ATAR is just entry into the course you want this year. Low ATAR is entry into the course you want, but it might not be until next year.
Correct. Yep, absolutely. So look, just a bit of information there. So if you are interested in enrolling and would like some more information about the course that we haven't addressed here today, I've got the contact details there, the email for us, and the link for how you can apply directly to the program. If you've already accepted, welcome. First of all, we're looking forward to having you here in Bathurst. The O week, the orientation week, commences the 21st of February, and our program, the first classes, commence on Monday the 28th, so a week after O week, at 9 a.m. in the building you can see in the picture on the screen there. So that's our foyer. That's where we have our introductory activity at 9 a.m. on the first day. So look, that's just a bit of a brief overview of their program. As I said, happy to have any more questions. Happy for people to email us through if you want some more information about the course and the offerings that we have here. So thank you very much. I'll stop recording now. Yep, you're on now.
Welcome everybody to a building tour. I'm going to start outside the building. Actually, it's actually raining, so not a good time to be here. This is the engineering building. When you arrive at engineering, you'll come through the doors behind me. You'll get a card, which will allow you entrance into these doors and all parts of the building. So this is the foyer of the building. Behind me there is a very large screen, which is we use for various presentations, public events, that kind of thing. There's our engineering office. Tracy, who normally sits there or perhaps upstairs, she knows everything. If you have a problem with any part of the course, see one of the academics or see Tracy and she will sort it out. Up the golden staircase are the academic offices and various admin offices. So what I'll do, I've got the foyer behind me here. I'll take you first to our classrooms and the labs. So come through these doors here. All right, this is one of our classroom meeting rooms. We also call them labs. This one is called the yellow lab. They're themed, color themed. I'm sure you get the idea. And that combines to another room behind. So we do some of the classes in here. We've got a big whiteboard. You can see this is last time I ran a tutorial about how to analyze trusses. There's a lot of stuff left up on there. Going back out into the hallway then, we'll move down this hallway towards our materials labs. First on this side, not sure where the light switch has gone, but this is our student computer lab. So this lab is always open. When you have a card for the building, you have access to the building 24 hours a day. So you'll generally find students in here working. Are there the lights? Okay. Moving further down, here's where we're getting to our materials labs. So this is the structures lab. Over this side, we've got some concrete and steel testing machines. We crush various pieces of concrete. We stretch steel to see how strong it is. This is our concrete crushing machine, and you can see the various bits are broken here. You'll get to crush concrete to see how it breaks and why. Down here, we've got a beam testing machine, and there's some various samples of concrete over there that students have made in their other labs. Got an outside door there as well. This is one of our larger machines for doing Sharpie testing. That's a property of steels. You'll learn about that when you come. And then civil engineer, of course, is not just structures. There is water, there's soils and geotech. So taking you now into the water lab. This lab is both for water quality. So we've got various chemistry and water quality stuff over here. And on this side of the lab, we've got hydraulics. So this is a flume tank. We get water in here, it flows down in here. And we use this flume tank for analyzing flow. You get to make waves in it, see how the water behaves, all that kind of thing. So that gets used in the classes as well, and in the topics. Then going back up the hallway, I want to show you at the far end there, we've got what we call the maker space. And this is, again, a student area. I'll be frank, it's actually a kind of workshop play area for you guys, okay? We've got some 3D printers. We've got various CNC routing machines and tools and that kind of thing. And it's in this room where a lot of students spend time, they make prototypes of things. If they're doing group work, they build models of things, test things out. So there's various leftover, it's a bit of a mess right now, there's various student models of things which are left over. Various things which people have 3D printed. This was a student's project of a bird nesting, something to do with bird nesting. So they made various shapes and sizes, tested them out. There's various other things there that students have done. So this is an area you guys are free to use, to support your engineering studies. I'm going to go back out into the foyer then. So this is the foyer and the main entrance where we were at first. There's an outside courtyard out this way. And the big hexagon logo it's a tribute to engineers. Engineers Australia has a hexagon as its logo. Sorry, there it is. And we've got a hexagon there. And each side of those, the steel is given a slightly different treatment, which is why it's all different colors. You'll learn more about that as well. Is what we call the honeycomb area now. This is basically the student area. It's a large hall. There's various booths, offices, screens, tables, chairs, that kind of thing. This is basically your student office. So when you guys are here, this is where you guys are free to hang out, to work, to do all the things you need to do. So we have various individual meeting rooms over there. But this is the common area where a lot of students do their work. There's a lot of group work involved, so they meet here, spend their time here. And you can see in the background some various, somewhere there, various screens and computers and so forth, which are there for student use. And on this side, a little kitchenette. So we view this as your office, okay? So we'll give you facilities, set you up, and it's a workplace. So it's our workplace as staff, it's your workplace as student engineers as well. There's very much the attitude that you're not engineering students, you are student engineers, in that you're engineers who are in the student phase of your career. So there's a sort of level of professionalism from day one about that. Do you guys have any questions or any other parts of the building you want me to go back to?
No, that was pretty good, thanks.
Good. As you can see, it's a fairly small building. There's an office upstairs I haven't showed you, but you'll get to see that as well. Do have a look for the Rube Goldberg machine. Josh might be able to throw a link in the comments here. The Rube Goldberg machine is what we're doing, what we call Challenge Zero. So in the first 2 weeks, you guys have to actually create a machine that works. And Josh is going to post a video of what previous years have done. So we get right into it. While other students are sort of having their orientation and, hello, I'm Professor so-and-so and we'll teach you lots of maths. You guys are actually in there building stuff. So it's a very practical course from day one. In any case, I'm looking forward to meeting you both in a couple of weeks' time. And I hope you really enjoyed here.
Thanks heaps.
Thanks, Peter.